All right, good afternoon, class. Welcome and to our second day of notes here in chapter 1. So today we're going to continue our work with these recursive sequences, and we're going to look at basically some specific patterns, and we're going to probably mostly focus more though on geometric ones, but it's still nonetheless we will look at arithmetic ones possibly in the assignment. Anyway, to start us off, we really want to talk about some vocabulary here. So there's some terms that will pop up in your notes, and it's going to be very important to know the meaning of them because it will help you in writing the recursive forms of the sequences. So the first word right up here, as I already have it all ready to go for you, is depreciation. So when we talk about depreciation, it's when something goes down in value. Okay, so it's decreasing. You'll also see other words like decay and loss that might be used in the problem. So anytime you see those words, think about the sequence as you look at as the next term and the next term that it's going down in value. The other word, appreciation, okay, in mathematics, instead of English, a lot of times when we think about being appreciated, it's being loved and belonging and stuff like that. Appreciation in the math and like economic terms is also actually a good thing. It's usually when something goes up in value. So it's like when you start to invest money, things, increase, or something grows, or something gains something. Okay, sometimes growth, though, might not always be the greatest thing, especially when we talk about bacteria growth, and as we've even seen with the coronavirus this year. Anyway, the last thing that I want to talk about before we get into kind of some practice things here is talking about this particular term, U sub 0. Remember how we talked about U and a subscript with a number in it. The 0 means basically it's the 0 term, or it's the starting value when no time has passed. So a lot of times yesterday we were talking about U sub 1, but U sub 0, it is very practical to use, and we tend to use it more often when we put sequences in context of problems, because usually we'll have an initial value or a starting value. So we started at 0, and then U sub 1 actually represents like the first year or the first day or the first month or the first unit of time after the starting value. So lots of times in context, we'll use U sub 0. When it's not in context and it's just a general pattern, we tend to use U sub 1. That's kind of the big difference of it. All right, so today one of the things we're going to really focus on is dealing with percentage gain or percentage loss. So what happens is we're going to start talking about this common ratio. And remember, we like to use the letter R for the common ratio. So the common ratio, how we figure out what we're going to multiply by, is always going to be this value. It's always going to be 1 plus or minus a percentage change. So remember that 1 is like saying 100%. Okay? So percentage change, many times you're going to have to change to a decimal. So, and I'll demonstrate this here in these examples here. Or the space down below, how it works. But what happens is when you combine the percentage with 1, okay, you don't go 1 plus, say, 20%. You got to change that 20% to the decimal form of it by moving it 2 decimal places. So if you remember that probably from your Algebra 1 days or even just kind of some general math classes. So to give you some examples on why we have plus or minus, it all depends on whether it's depreciation or decay or appreciation and growth. When it's growing, we're adding. Okay? When we're depreciating, we're decaying, we're subtracting that percentage. So just to kind of give you some examples. So I'm going to have like 20%. I'll even have like 3%. Okay? And I'll even give you kind of a weird decimal, say like 2.5%. Just to kind of, and I'm again just making those right up the top of my head here. Okay, so now, how do I write it as a decimal? So remember 20%, you move the decimal place over 2 spots. So it's like saying 1 minus 0.20. Okay? And you get the R, the common ratio, is 0.8. Later on in like 1.3 and 1.5, it's going to be okay to leave it in this form, 1 minus 0.20. Sometimes it's easier to see. Now when it's like a single digit here, remember we still move it 2 decimal places, so sometimes we actually have to put a 0 in front. Sorry, that kind of had a little delay there. So we go 1 minus 0.03, and we get like 0.97. So think of this number as what percentage remains. If I remove 20%, 80% remains. If I remove 3%, 97% remain. Okay? So on the last one, 1 minus, move that decimal place over 2, so 0.025. Okay? So we get 0.975. So if I remove 2.5%, 97.5% remains. Okay? So now I'm going to keep those same percentages and just do it for appreciation. So again, it was 20%, 3%, 2.5%. Okay? So 1 plus p. So the only thing that happens is my sign changes. So now I'm going plus. So you can think of that as a parentheses. And in the calculator stuff, we're going to show you later here how that you can just leave it as such. But you could also write it as 1.20. We go 1 plus 0.03. So we get 1.03. Okay? 1 plus 0.025. And we get 1.025. Okay? All right, so just to show you just some more examples, actually I almost skipped a thing, probably one of the most important things. On the back side, we're going to talk about this concept called compound interest. Oh my goodness, if there's anything I could teach you in this class, it's this concept right here. It's like one of my favorite concepts. It's the most useful concept in actually, when we talk about life in general. This is a thing that I think students really need to know. And how compound interest works is, or what it is, it's when the interest you make on your money makes interest. So many of you might have, a debit card that's tied to, maybe a savings account or a checking account at the bank. And so from time to time, you might go online and check your bank account, or you go to the bank and get an update of, what your balance is. And once in a while, you'll look and be like, how come I see this interest 2 cents or interest 1 penny from time to time? What happens is the bank gives you money for keeping money in the bank. Usually it's a really, really small percentage, but occasionally you'll get some pennies. Some of you, depending on how much money you have, you might even get some dollars once in a while. I know even on my accounts, I kind of laugh and chuckle. I'll see 1, 2 cents from time to time. Okay, but this thing is huge, and we'll talk a little bit more about it on the back page. All right, let's dive into some examples here for you today. So number 1 here is exactly what we were just doing before talking about compounding interest. So it says, what would you multiply to show? So really what I'm asking you to do here is I'm asking you to simply just find the R value. So 2% growth. Since it says growth, that means plus. So I'm taking 1 plus 2% as a decimal. Remember, move it over 2 spots, 1 plus 0.02, and I'm completely fine if you leave it like that, or if you write 1.02, I'm fine with that also. If I do the second one, growth again, move the decimal over 2 spots. So if you write it as 1 plus 0.0345, that's just fine. Or if you wrote 1.0345, that works for me too. Okay? All right, the second one's here. Look at how they say decay or loss. 5% decay or loss, so that means subtract 0.05. Remember, move that decimal over 2 spots. So we get 95. So if I'm losing 5%, it leaves 95%. 31%, move the decimal over 2 spots. 1 minus 0.31 leaves 69%, or 0.69 as a decimal. Okay? So hopefully that will help you, I think, with the first homework problem. All right, number 2 is now we start to kind of put it in a little bit more of a context. So number 2 here says a $500 computer you bought is depreciating each year. So my stepkids, they bought computers when they went to college so that they had a device to use. And so what happens is over time, it will depreciate. It gets worth less and less. Think about some of you that own your own cell phones. The iPhone 11, I think, is like $1,200. But after a year, you probably can only maybe get $600, $700 for it. After 2, 3 years, like my phone, I have an iPhone 6. I think mine's like 4 or 5 years old. I'd probably be lucky to get $50 for it, I think. Anyway, getting back to the problem here, you can see that the depreciate, or it's depreciating, or it's going down in value each and every year. We can actually, visually see that. So the first thing here, it says find the common ratio, the number you multiply to get the next term by. So what we're trying to figure out is figure out this R. What am I timesing by that R value to go from 500 to 400? So remember how we found R from yesterday. You take the previous, or the next term, got a little ahead of myself, and divide it by the previous term. Okay, so I can take 400, simply divide it by 500, and I get my R value. So quickly on my calculator, I apologize, I kind of left that on the screen there. We'll get to that. Some of you may be looking at that going, what in the heck is that, Mr. Bartz? And we'll be demonstrating that on the next page. 0.8. So I got R as 0.8. So now it says, what is the percent of change? The percentage of your computer's value that is being lost each and every year. So if I think about this, it's like 1 minus P is 0.8. So I think to myself, what is P going to be? Many of you intuitively would say, well, if I have 80% remaining, that means P must be 0.20, or it's 20%. Now, if you're just like, oh, I don't see that quite yet, if I subtract 1, I'll have negative P equals negative 0.20. Since they're both negative, you divide by negative 1, and you get P to be 0.20. So you can solve it algebraically also. Okay? So now, here's the cool part. Write the recursive rule for this sequence. So remember, recursive rule has two parts to it. You define the first term. So if I look up here, here's my first term. See how it's defined as 0? The 0 term, the starting value. So u sub 0 is 500. Then I always write u sub n equals u sub n minus 1. You probably have seen that many a times now and realize, okay, I just write that. Next term equals previous term. And then what am I doing to get it? What mathematical operation? I was timesing by R, which I found right here. I'm just timesing it by 0.8. And so if you want to start to convince yourself a little bit, take the 500, times it by 0.8, see that you get 400. Times it by 0.8, you see that you get 320 the next term. Hit enter again, look at that, I get 256. It's matched my pattern. Life is good. Okay? All right, that takes care of the first page. Let's flip to the back side, and this is where we start to get into this concept of compounding interest. So this example kind of takes you through the process of how compounding interest works. So let's kind of set the tone of the problem here. It says, suppose you have $500 and you deposit it into an account that earns 6.5% annual interest and no more deposits or withdrawals are made. So what does it mean to be annual? Annual is like saying one time a year. Like you'll keep the money in there and at the end of the year, they're gonna give you 6.5% of $500, okay? So how it works is we wanna write the recursive rule. So to start this yearly and annual are basically one and the same. So we start with u sub 0. We initially deposited $500 into our account. So now u sub n equals u sub n minus 1. And so what's happening is I get not only my $500, but I get an additional 6.5%. So in essence, it's like saying, all right, I get the 100%, which is like we're doing basically this 1 plus p part here, okay? So p is 6.5%, move that decimal over. So it's like saying 1 plus 0.065. And I got it written. So now what I can do is it says, find the balance after 1 year. Okay, so I can say, all right, if I take 500, and now if I times it by, and this is where just keeping it in the parentheses form can be, really makes it pretty easy. So I can just type it right all in my calculator, and there we go. I have it, $532.50. Nice. So with the bank just keeping my money, they're going to give me $32.50 at the end of the year. That's kind of nice. Okay? So now, On the next problem here, it says semi-annually. So what does it mean to be semi-annually? Well, annually we know yearly, but semi, we've seen the word semi before in geometry when we talked about the word semicircle, because the circle in half. So in essence, here we're talking about a half a year. So what happens is we get to figure it out 2 times a year. So what happens is we're going to cut the interest in half. However, they're going to basically pay us interest on the $500, or half the interest on $500 at 6 months, and then they're going to pay another set of interest at the end of the year, but only half. But what happens is the interest you earn at the 6-month point gets interest also at the year point. So your interest starts to make interest, okay? So how we start this off is just like we did here, u sub 0 equals 500. That's always going to kind of be the same. The second part, the first part of it written is the same, but now we're going to go 1 plus, and we take that interest rate. However, we're no longer dividing by 1, but we're dividing by 2. So now, I am going to backtrack for half a second. We found this term right here. I'm just going to define this term as u sub 1 because we only did one multiplication. So what happens now when we calculate this out here, we're not finding the balance after 1 year is not u sub 1, but it's u sub 2. Okay? So what has to happen here now is if I want to know the balance is, I take $500, and it's getting multiplied by 1 plus that interest rate, but we only get half of it the first time. So when I hit enter, this is actually my balance at 6 months, okay? Not at the end of the year, after 6 months. So now I have to take that answer, that $516.25. Notice how it's actually half this value. So now that $16.25 gets to earn interest, okay? So now it's getting multiplied again by 1 plus 0.065 divided by 2. Close parenthesis, hit enter. Whoa, what happened there? Oh, I see what happened. So I apologize. I'm going to have to kind of, I forgot the little plus sign there. See, even Mr. Bartz messes up, and this is kind of the challenging part for Mr. Bartz in this calculator once in a while. You gotta really be careful and watch what you enter in. So I'm just kind of starting over, boom. So I go times by parentheses 1. Please take the plus this time, thank you. This time it did it for me. I kind of noticed that, whoa, I almost messed up again. Wow, 0.65 divided by 2. So you can see how just little typing errors, even on your calculator, Mr. Bartz even makes them once in a while, can cause some issues. So if we look here, I know my answer should be close to this, but a little bit more. So what happens is, because my interest made a little more interest, I now made, if I round to the nearest penny, $533.03. So you might be saying, whoa, whoopie-dee, Mr. Bartz, you made a whopping 53 cents more. I can't even buy a candy bar these days for that. True. However, okay, we just did this for 1 year, and we only did semi-annually. Let's see what happens when we do the last one in this example, which is monthly. Monthly, if we think about how many months there are in a year, 12 months in a year. So the problem starts exactly the same. U sub 0 equals 500. Now when doing the second part, u sub n equals u sub n minus 1. So we go 1 plus 0.065, and I divide it by, now instead of 2 times a year, dividing it by 12 times a year, okay? So now the term I'm actually finding is not u sub 2, but u sub 12. So when I do this problem, wow, okay, you're going to see that it's going to take a little bit of work on this calculator. So 500 times, parentheses, 1 plus 0.065 divided by 12. Close my parentheses and I hit enter. So this is the balance, not after 1 year, not after 6 months, but after 1 month. So if I start at January 1st, this would be the balance on February 1st. So now I have to times it by that same value, 1 plus 0.065 divided by 12, close my parenthesis, hit enter. So there's my balance after 2 months. Man, I gotta type this again and again. Well, here's the thing. Once you have the answer times it, if you keep on hitting enter, it will take the answer and do that multiplication again. So here's after 3 months, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so now we're up to, okay, a little bit more, not a ton more, but $533.49. Sweet. Okay, if I look at here, all right, Mr. Bartz, look at this. We made almost $1, 99 cents more. Probably buy a candy bar for 99 cents these days. I don't know, I haven't bought a candy bar for a long time. Now, some of you might be going, geez, Mr. Bartz, this took a little while. Is there a faster way we can do it on our calculator? And boy, what if I change this monthly to say like weekly or daily? Oh my goodness, 365 times I'd have to do it to do daily? That would be crazy, okay? There's gotta be a faster way. And guess what? There is. And we're gonna show you how you can set up these recursive sequences in your calculator, okay? So, to get your calculator set up, the first thing we need to make sure we do is this. So pause the video for a second if you have to, take out your calculators. If you don't have your calculators right with you, but you use the online one, again, go down to on your Chromebook, in the bottom corner of it, there's like that little circle where all your apps are. There should be an app downloaded on there for the TI-83 or 84. They did that last spring, and Texas Instruments has kept it for us, so the calculator should still be there. But if you have a handheld one, too, I'd take out my handheld one. Sometimes that might be easier to use, too. All right, so I'm just hitting clearing my screen. So getting back here, I'm going to hit the mode. So, but it actually says, okay, press the mode button. So mode's right here. Press that button. Now it says change function to sequential mode. So depending on your calculator, you go down, and I think mine's already been done, but many of you are like this. The function is highlighted. Okay? Some of you might not be. What you need to do is move your cursor over to SEQ where it says sequential mode or sequence mode, and make sure that is highlighted. We're going to be working with sequences, hence why we're going to sequential mode. Okay? Once you have that done, go ahead and hit the Y equals 2 key. So this Y equals 2 key puts you in this kind of funky mode. Instead of Y equals, it's in this sequential stuff. And we got 3 things in here that we need to talk about. So just for fun, I know that some of you might have stuff in here. Some of you it might be completely blank or hardly have anything in it. So what I'm going to do is I'm just going to clear everything out. Okay. Well, it won't probably let me. It won't let me, so keep that first term as like 0 or 1. So I'm just going to clear this out, and it'll let me clear that out. But it looks like it won't let me clear that out. Oh, it does. Okay? So now, here's the thing on how recursive definitions work in your calculator. We're going to work with this specific problem here. It says the following recursive rule will calculate your balance on $500 deposit in your interest in your calculator weekly. So if we think about weekly, remember there's 52 weeks in a year. So what you'll see is, notice here how they go 1 plus the interest rate divided by 52. So we have this u sub 0 equals 500, and then they just put the multiplication piece in front. I will flip these on the calculator. And I think it's just so much easier to do. So how do we get this on our calculator? So the first thing that you want to make sure you do, however you have defined your first term, that number has to go there. These are the same. Okay? So when we're in context problems, this number should always be 0. I hit 0, enter, I can go to the next line. So the next line, you're actually typing in this information. So the question is, how do I get this u sub n minus 1? So this is the directions right here on how you get the u sub n minus 1. I'm going to type that piece right there in my calculator. So how I get the u is it says second 7 for the U. So second 7 for the U. My U popped up. So I want to have it be a parentheses. And now I got to get the N. So you type in, you hit this key on your calculator, xt theta n. You'll see right here, xt theta n. It's basically your x for in the y equals. They just use n because we're in sequential mode. And then I can type in -1 parentheses. So they don't do subscripts. They use parentheses as subscripts. Then I can just say times, and now I can type in 1 plus 0.065 divided by 52. Okay, that's all matching. Close my parentheses. That looks beautiful. Okay, so now the last line is always what the starting value equals. They'll say U of min. So it's like basically saying, all right, you define the minimum value or the first value at 0. And on this line now it's saying, what is that value equal to? We're going to say 500. So the next one here is just if you wanted to do 2 of them at the same time. We actually won't be doing that. Okay? So now we want to start to see these values. Okay? So what you can do is you can use a table to see it. But it's always good to have your table starting at a good value. So this is a very important command. So second graph, okay, if I go to second graph, this is going to pull up the table. See how my calculator is thinking there? Here it's saying n of 57, so it's like saying the 57th term is what it's worth. I really want it to be the 52nd one. So I could probably just use my up arrow and get there. Okay, and you can see, oh, look at that, $532.89. I feel like I typed something in wrong. Oh, because I'm on 51 instead of 52. There we go, 533.56, because I know it should be a little bit bigger. Okay, but the other way of getting to it quickly, okay, is this: change the table set. So what you can do is, and this is very important, second window. You can start it at any value you want. So you can start it at 0. In our case, say we wanted the 52nd term. Then if I go back to the table, let it think, it will take me exactly right there. Make sure you highlight it so you can get the exact value. So like to answer our question here now, it says how much money will you have in your account after 1 year? So U sub 52, we just saw there was $533.56. Okay. So now the last question here says find the balance after 2 years. So if I think about 2 years, I'm not looking for, U sub 53. 2 times 52, 2 years, is actually 104 weeks. So now this is where that table set comes into play. Second window, change that table set to 104. Second graph, let it think for a little bit, and sometimes it takes a little bit. So now what I see is, wow, now my money, $569, okay, and 37 cents. And I can see that they've rounded it nicely for me. So as you start to see, your money's actually getting a little bit bigger and a little bit bigger because your interest starts making interest. So if you keep this in for a long time, wow, it can grow fast. All right, so hopefully these examples will help you with your worksheet today. I apologize, these are some old notes, so ignore those things at the bottom. But please work on worksheet 1.2. Go to the assignment part and complete that. If you get any questions on it, send me an email, let me know. We'll try to do a Google Meet or even watch the video of it. So I'm trying to make sure I have as many videos for you as possible to help you out. All right, enjoy the rest of your afternoon. We'll see you tomorrow, if not sooner.